Hello class. Today what we're going to talk about is the Pythagorean Theorem. Now I know most of you are already using the Pythagorean Theorem. You've been doing this since middle school somewhat. So that's fine. We're going to go over it again, going to do some other stuff, and show some other things we can do with the Pythagorean Theorem. So what the Pythagorean Theorem says is that if you have a right triangle, then the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the two legs. So most of you know this as a squared plus b squared equals c squared. And we don't care which one's a, which one's b, as long as those are the legs, those are the short sides. The important thing is that c is always that longer side. It's always the hypotenuse. All right. Now, some little things, just a little shortcut stuff. Here are some common Pythagorean triples. Okay. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. And what a Pythagorean triple is, that is numbers that work out to make that right triangle, a squared plus b squared equals c squared, and they're all perfect integers. Okay, no decimals, no fractions, no square root of 3, none of that. All integers, and so we call these Pythagorean triples because they're really nice and they're pretty, and the three of them. All right. And the thing about this, 3, 4, 5, that's the one you see the most often. It's the easiest one to remember. But also, any multiple of this will also be a Pythagorean triple. So 6, 8, 12, 10. That's just 3, 4, 5 times 2. 3, 4, 5 times 3, 9, 12, 15. Right? Or times anything is going to work. So these are the common ones. These are just multiples of those common Pythagorean triples. So what we're going to do here, we're going to find the value of x. And we want to know, is this going to be a Pythagorean triple? So we look at this and we see it is a right triangle, so we can use Pythagorean theorem for this, so that's good. X, that is our long side, that's our hypotenuse across from the right angle, so that goes into the C position. So we have x squared equals 5 squared plus 12 squared. Take care of those squares, add them together, we get 169. Take the square root of x, square root of 169. Now remember, everything does have two square roots, a positive and a negative. However, in this case, we're looking at the length of a side, and negative doesn't make sense for lengths. So we're just going to be looking at the positive square root, which is positive 13. And so x is 13, and since that is an integer, and these are also integers, all three of these are, then this is a Pythagorean triple. Okay. So what I would like you all to do is this one here. Find the value of x, and then tell, is this a Pythagorean triple or not? Right. So pause the video, work that out, come back. Okay, let's see how you did. Pythagorean theorem, we'll plug in. Now notice this time x is not the hypotenuse. 14 is the hypotenuse, so that's our c. We'll plug this in, work this out. We've got 147. Square root of 147 is 7 square roots of 3. 7 square roots of 3 is not an integer, and so this is not a Pythagorean triple. Right? Still a right triangle, just not a Pythagorean triple. Right? This gets used a lot. It's in all kinds of building and construction and stuff like that. We use Pythagorean theorem because you have a lot of right triangles and right angles and things. All right, so here we have a skyscraper connected by a skywalk. It's got some support beams here. And we want to figure out how long are these support beams. Right? So we're building a skywalk, got to support it. You know how long those beams should be so that it reaches. Right? Gives us the lengths. We notice that both of these triangles have the same lengths. We've got side angle side. These are congruent triangles, so x is going to be the same on both of them. And so we just plug this in. Use Pythagorean theorem. X is our hypotenuse, and so that's going to be our c squared. Now these are some lovely decimals, and so it's not going to be a Pythagorean triple, obviously. So we take the square root of both sides. We have this and this. We're just going to take this and stick this straight into the calculator. Square root. Make sure you put parentheses around stuff where you have them there, and hit enter, and you get it is approximately 52.95. So the length of each support beam needs to be approximately 52.95 meters. Right. That's it. I mean, it's Pythagorean theorem, not hard stuff. So I want you to answer these 3 here and then come back. All right, let's see how you did. Number 1, x is 2 square roots of 13, which is approximately 7.2. So that is not a Pythagorean triple because it's not an integer. Number 2, x is 4. This is 3, 4, 5, nice little Pythagorean triple. Over here, we need to figure out d. How far away are these support wires? And Pythagorean theorem, we get about 3.32 feet. So there it is. Now, there are some other things here. What if we have a triangle? We don't know, is this a right triangle? Is it not a right triangle? Well, we can use the Pythagorean theorem for that. The converse of the Pythagorean theorem. It says that if a squared plus b squared equals c squared, then this must be a right triangle. All right? So it's going the other way around. So let's take a look at this. We want to know, are these right triangles or are these not right triangles? So let's look at triangle A. Now, I don't know what the square root of 113 is. Let's see if we can figure it out. But this does appear to be the hypotenuse, right? So we have 8, 7, and square root of 113. It's going to be more than 10. So it's got to be the long side. So that goes into our C. We plug this in. C squared plus A equals A squared plus B squared, right? Hopefully, we don't know. So the square root of 113 squared, that's just 113, and 49 and 64 there. Add them up, 49 plus 64 equals 113, and 113 does equal 113. So this is a right triangle. Let's try it over here. Here, this is apparently the hypotenuse. This is going to be square root of, that's going to be pretty close to 10, so this should be pretty close to 40. So yeah. All right. Let's see what we got here. This is my C. Plug that in here. Squared plus 15 squared plus 36 squared. They're breaking this out. Since this is all being squared, we can square the 4. We can square the square root of 95. All right. So that gives me 16 times 95 equals 225 plus 1296. And we get 1520 and 1521. They're close, but they don't exactly equal. So, not a right triangle. Okay, now I'll have 2 here for you to do. Pause the video, tell me, are they right triangles? And then come back. Let's see how you did. 4 is a right triangle. 5 is not a right triangle. If you need the work, here it is. Plug it in. Here's my long side, so that goes in for my C, which gives me that 306 equals 306. That works out. Over here, 26, that's my long side, that's my C, and there it is. Gives us 676 equals 680, and it does not equal 680. So not a right triangle. But what kind of triangle is it? Is it obtuse? Is it acute? What kind is it? And that's what the Pythagorean Inequality Theorem says. And this is going to be new to y'all mostly. And what this says is that if c squared is less than a squared plus b squared, triangle is going to be acute. If c squared is greater than a squared plus b squared, the triangle is obtuse. Now, very important, c is always the longest side, every time. It's not going to be the hypotenuse because these aren't right triangles, so they don't have hypotenuse. But it is the longest side. So basically what this says, if you look here, if c exactly equals a squared plus b squared, c squared does, then we have this right triangle. If c squared is less than that, well, what that means is this long side isn't long enough to reach over here and make a right triangle. So it's too short. And so it's going to be, your angle is going to be smaller. Right? So it's an acute. Over here, the red one, D is too long. It reaches too far. It doesn't reach here. It's got to go longer. And so your angle comes out here. And so now we have an obtuse angle because our side is too long. Right? You can go back to the hinge theorem. Right? If the longer that side is, the greater this angle is going to be. Right? So let's take a look at this. First, we want to verify that these 3 lengths can form a triangle. Okay? And once we know they form a triangle, we want to know, is this going to be an acute triangle, a right triangle, an obtuse triangle? What kind of triangle are we dealing with here? So we're going to use the Triangle Inequality Theorem, which says that the sum of any 2 sides of a triangle must be more than the other length. So here we go. We're going to start with the 2 short ones. does this come out to more than the longest one? And yes, it does. And really, that's the only one you need to do. I've got to have it for all three of them, all three combinations. But really, if the two short sides add up to more than the longest side, then you're good. Because if you're using something other than the longest side, then you've always got one side that's already longer than that middle side without adding anything to it. So, of course, it's going to be longer than that short side because the other two sides are already longer than it. So this works out. All three of these are longer. This is really the only one that matters. The two short sides greater than the longest side. So let's see what kind of triangle is it. So what we're going to do is we're going to use a squared plus b squared equals c squared. Remember, c squared is always the long side. So that's 6 plus 1. That's the c squared. And these are a and b. We don't care which one's which. So there it is. And we don't know. Let's see. So we plug it in. We simplify this. Get that. Add those together. And we end up with 37.21 is less than 45.53. So this means our c squared is too short to reach and make this a 90-degree angle. And so it's a smaller angle. It is an acute angle. All right, so we have an acute triangle. Let's take a look at this. We have two here for you to do. 3, 4, and 6, and then 2.1, 2.8, and 3.5. So what I want you to do is pause the video, work both of these out, and then come back and see how you did. Alright, so hopefully you have them both already worked out. Let's see here. 6 does come out to be a triangle, and this one should be obtuse. And here's the work for that. Here it is checking their triangle. Notice I just did the two short sides longer than the third side. That's all it takes. As long as you make sure the short sides are more than the long side, you're good. Plug it in, and we end up with 25 is less than 36. So our c squared is more than a squared plus b squared. So it's too long. It won't make a 90-degree angle. It's going to go past that, so it's going to be obtuse. Number 7, this is a right triangle. Here it is verifying that it's a triangle. And here we have, works out, and 12.25 is equal to 12.25. Since they equal, it does satisfy Pythagorean theorem. So this is a right triangle. And that is it for Pythagorean theorem. Hopefully most of this was review for you. The inequality thing was probably new. Remember, if c squared is less than a squared plus b squared, it's an acute triangle. If it's more than a squared plus b squared, it's an obtuse triangle. Right? Hopefully that helps. I will see you next time.